Hello everyone, welcome to the next lecture on creating orthomosaic maps step by step. One of the most valuable outputs in drone surveying is the orthomosaic map. This map provides a high resolution, geographically accurate aerial image of the entire survey area. Orthomosaic maps are widely used for site analysis, land measurement, construction monitoring, and infrastructure planning. In this lecture, we'll walk through the step-by-step process of creating an orthomosaic map using drone mapping software. Step 1. Upload drone images. The process begins by importing the aerial images captured during the drone survey into the photogrammetry or mapping software. These images usually contain embedded GPS information, which helps the software understand the approximate location where each image was taken. Once all images are uploaded, the software prepares them for processing. Step 2. Image alignment. The next step is aligning the images. During this stage, the software analyzes all the photos and identifies matching features between overlapping images. These could include buildings, road markings, terrain patterns, or other visible elements. By comparing these shared features, the software determines the exact position and orientation of each image. This step creates a sparse point cloud which represents the basic structure of the surveyed area. Step 3. Ground control point integration. If ground control points (GCPs) were used during the survey, their coordinates are imported at this stage. The software identifies the GCP markers in the images and uses their known coordinates to improve the positional accuracy of the map. This step is especially important for professional surveying projects that require high precision. Step 4. Dense reconstruction. Next, the software performs a more detailed analysis to generate a dense point cloud. This dense cloud contains millions of data points representing the terrain and objects within the survey area. These points provide the foundation for creating accurate elevation models and surface maps. Step 5. Orthorectification. One of the most important steps in orthomosaic creation is orthorectification. During this process, the software corrects distortions caused by camera tilt, terrain elevation changes, perspective differences between images. This ensures that every pixel in the map is positioned correctly relative to the Earth's surface. Step 6. Image stitching. Once the corrections are applied, the software stitches all the processed images together into one seamless aerial image. The software blends overlapping images carefully so that the final map appears smooth and continuous without visible seams. Step 7. Final map export. After processing is complete, the orthomosaic map can be exported in various formats compatible with GIS, CAD, or mapping platforms. These maps allow users to measure distances, calculate areas, monitor site progress, analyze land features. Orthomosaic maps are often the starting point for deeper analysis such as terrain modeling and volume measurements. In the next lecture, we will explore how to generate 3D terrain models from drone data, which allows professionals to analyze elevation and landscape structure in greater detail.